Okay, this is a problem from the section of the book on the chain rule, and the instructions just say to compute the derivative. So when we're looking at one of these chain rule problems, we need to think about what the which functions are being composed. What's the outside function? What's the inside function? Or if you prefer to think of it this way, what's the f function? What's the g function? So when I look at this, I'll say, okay, y is equal to cosine of t e to the negative 2t. Now let's not worry too much about things yet, but I think that we can see, the thing that I like to say is kind of squint your eyes and see what the big picture is, see what the shape of the function is, and we see this cosine on the outside, and we're taking cosine of something that's more complicated. So our outside function will be cosine of x, and our inside function, I guess it's of t, g is t e to the negative 2t. All right. And so what the chain rule says is that the derivative is equal to f prime of g of t. So you take the derivative of the outside and you leave the inside the same, times g prime of t. So if we go through this, the derivative of cosine is negative sine. So we'll have negative sine of t e to the negative 2t times the derivative of t e to the negative 2t. Okay, so if your inside function is something kind of complicated like what we have here, then I do recommend that unless you're really comfortable with these things, you pause for a moment and write down the derivative of the inside part without worrying about what it actually is or trying to skip steps. But now that we have this, we can look at this and say, okay, we need to take this derivative here of t e to the negative 2t. And that's a product of two things. It's a product of t and e to the negative 2t. So we need to use the product rule. Okay, so we still have this sine of t e to the negative 2t piece. I'm going to set myself up with some brackets because the product rule is going to give me a sum, and I want the sine, this negative sine piece, to be multiplied by the whole thing. So, okay, so the product rule says I'm going to take the derivative of the first function, t, to get 1, and leave the second function the same. So e to the negative 2t plus, now I'm going to leave the t the same and take the derivative of e to the negative 2t. Okay, so again, because this is a little tricky, I'm going to write it down as just the derivative of e to the negative 2t and pause there so that I don't make any mistakes. And if you are already comfortable with this, then you don't have to pause and do all these steps. But if you feel yourself getting overwhelmed by the derivatives, if you feel like you're a little bit confused about what's going on, then take it step by step. It's what I do. All right, so now we look at this e to the negative 2t. If it were just e to the t, we would know the derivative is e to the t. But we have something more complicated in this exponent. We have negative 2t, not just t. So this is again a candidate for the chain rule because we're plugging in this slightly more complicated function, negative 2t, into the function e to the x. So we need to take the derivative of the outside part, the e to the x part, and we leave what we're plugging in the same, so we get e to the negative 2t. But then we have to take the derivative of the inside function, the function that we're plugging in, and we get negative 2. All right, and I want to rewrite this so it doesn't look confusing, like maybe I'm subtracting 2. Just remove that ambiguity. So we get negative sine t e to the negative 2t, and then times e to the negative 2t minus 2t e to the negative 2t. That's our derivative.